Thank you, Amresh, and welcome everybody after a long day. My name is Eckart. Apologies, I still have a German accent. I've lived here many years. It somehow follows me, sticks to me, but if you need a translation, just ask your Samsung S24. I'm sure it can do it for you. And it occurred to me the other day, I think this part of Somerset West, we always used to call it Sauerkraut Hill because there was quite a high density of German population here in Somerset West as well. So that's quite a while ago. Yeah, so today I want to talk a little bit about innovation in the data center technology, and what we've seen really over the last 15 years in the modern data center has been all around optimization, making things smaller, making things better, but not really, I would say, the introduction of new technologies. And it's now starting to take shape, take place. So I would just want to touch on that. So a couple of the elements that we're going to talk about is what drives the change, what is demanded on the infrastructure, what other consideration does a data center operator have to adhere to, and then the actual topic of the talk about the different ways of high-performance cooling, and after that, hopefully, some time for questions. So what's driving the change that we've seen from a data center environment is really the emergence of high-performance computing, new applications coming into the mainstream, such as artificial intelligence, but there are others. There's obviously gaming applications. There's applications that we're hosting or are going to be hosting in South Africa with regards to space exploration and terrestrial analysis of space data. And yeah, other high demand applications that are changing the landscape of the hardware that goes into a data center. ESG is a big topic for any data center operator. Data centers traditionally being perceived as high consumers of power and high consumers of scarce water resources. So quite a bit of pressure on ESG, also driving a lot of change and new thinking into the data center environment to do things differently. Obviously cost, always a consideration. The data center fabric itself is changing from pure hyperscale type core environments to more distributed combination of core and edge environments that introduces additional costs that we need to always keep as low as possible. So what's been happening on the infrastructure side? The CPUs that we are finding on the server chassis that we are asked to host really have had tremendous development. Some of these chips now pack up to 8 billion or more semiconductors, traditional silicon-based chipsets, 8 billion of them on a single chip. So the power consumption has really multiplied from figures below 100 watt, 100 watt. Now we're seeing 400, 700 watt chipsets due to the increasing power that they have, and that obviously generates additional heat that we have to dispose of in the data center environment. Overall, putting a few of these servers in a rack, traditional data centers started out maybe with 3, 4, 5 kilowatts per rack. We've had implementations of up to 15, 20 kilowatts a rack, but we can already see that air cooling is going to reach its limitation in terms of what it's able to cool. So for us, it's becoming all about enhanced cooling requirements. Other considerations, in addition to the efficient way that data centers have to operate and continuously improve their efficiencies, the data center environment is very tightly regulated and very much bound in terms of having to adhere to very strict conformance deadline regulations, really. Some of you may know the tier certification system. Certainly have to maintain our tier rating that is regularly audited. So the introduction of new technologies always has to be well tested and well proven and still be relevant in the field. So what cooling technologies do we have currently available? I think we are all familiar with the air cooling that we currently see in the data centers. And over the years that has been optimized. What we have now is the cold aisle containment concept that really makes sure that the cold air stays where it's meant to be, that it doesn't mix with the hot air that's coming out the rear side of the servers, and that really cooling is applied only to those areas where it needs to be applied within a data center environment. And we are seeing that that type of cooling is reaching its limitations. We're looking at about 20 to 25 kilowatt a rack, where we're finding above that air cooling is just simply not efficient anymore. So what's come along is a number of forms of liquid cooling and a couple of different implementations that we have seen, and we are starting to see more and more of them. The heat exchangers that are mounted at the back of the rack, fairly easy, small retrofit that is bringing the source of the cooling closer to the actual equipment. But even that has some limitations and some cost considerations. So additional forms of liquid cooling that we've seen is really the direct-to-chip cooling, where water is directed to a heat transfer plate that is mounted above the chip on the server chassis. And then we also have immersion-based cooling. So I'll show you a couple of samples of that. First of all, the liquid cooling direct-to-chip. There you see it on a sub-assembly. It's essentially a traditional cold water, hot water circuit that reaches the chip on the board through a system of small rubber pipes. There you see a picture of it, actually, how it comes out the back of the chassis, and essentially once the chassis are all stacked together in a rack, it connects to the back of the rack, and on the back of the rack you then have your cold and hot water pipes running through the data center. This technology is quite efficient, but it's quite expensive as well. It requires very high water pressures to be able to circulate sufficient water flow right through the heat transfer plate on the chip. And the cooling water itself puts certain chemical reactions, degradations on the actual, more on the connector side. So it's a technology that requires lots of regular servicing and maintenance, where the different couplers are engaged onto the chassis. So quite an intense technology to maintain. And obviously, for those of you that studied electronic engineering like myself, they always told us to keep the electrons and the H2O modules well apart. And the danger is obviously with leaking pipes that, it causes some fundamental disturbance in a data center environment. So the next innovation that happened afterwards is what we call immersion cooling. So in an immersion cooling model, what you really see, two different technologies. The one is a single-phase technology, the otherwise is called a two-phase technology. So the single-phase technology is a horizontal tank, as you see there, and the servers are inserted vertically into that tank, and the tank is filled with a very specialized, non-conductive, non-corrosive, non-harmful, biodegradable liquid with very good heat transfer properties. And that liquid essentially circulates throughout that tank to an external heat exchanger. So there's a low power pump that keeps the circulation of the liquid inside that tank going all the time. Some more pictures here. You see typical examples of these tanks. And in data center environments where you have to utilize liquid cooling because of high power densities, you would have a number of these horizontal racks sitting on the floor. Already you can see one of the cost savings would be that you don't need the raised floor anymore because you're not passing any air underneath the racks anymore, the servers. Basically, you have a row of these tanks standing in a section of the data center. Then I mentioned also the two-phase cooling. The two-phase cooling is very similar. It's a slightly different approach. The liquid is a liquid that has a relatively low boiling point. So in the two-phase immersion system, it's essentially a closed system. The coolant actually boils at about 50-something degrees, evaporates, and the evaporated liquid is passed through a number of condensation coils, and those condensation coils create the condensate again, and the liquid returns to the tank where it's circulated. So it's just another form of liquid cooling, but it's essentially a closed system, so it's a little bit more difficult to operate if you have to work on your servers or your networking equipment. You have to stop the system for a while, open the lids, as you see on this picture, work on the system and fire it up again. So what we've seen really is that the single-phase immersion cooling is a preferred form of cooling, and you already can get a huge number of different of these tanks, different sizes, different configurations, depending on the workload that have to be immersed for cooling. Now, these liquids are very effective. They require, though, a few minor adjustments, and the OEMs have by now embraced these adjustments as well. Your server boards no longer require the onboard fans. They are used for air cooling on the server boards themselves, and the connectors are aligned on the outwards facing edge so that it's easy to immerse the server vertically into the tank and work on the connections from the top. So some minor adjustments, but as you can see here, the large OEM vendors have already adopted it and offer immersion-ready servers, and more high-performance vendors, high-performance equipment are making this technology available. Here's just a quick overview on the different forms of cooling. So the different temperature bands essentially overlap, but what we are finding round about the midpoint of each of these temperature ranges, these different technologies really hit the limit of what cooling they can provide. Immersion cooling has already even run up to 200 kilowatt per rack, but it's still an emerging technology itself. So at the moment, the recommendation is up to 100 kilowatt per rack on immersion-based systems. Now here, just in a nutshell, what does it mean? What are the benefits, and why go through this? Essentially, what was found that just the server fans alone on a server can consume up to 20% of that server's power drain. So already by not having the fans on the board, we're saving 20% of our electricity bill. Over and above in the data center, we're finding about 30% of the costs of the data center, both on design and construction as well as operations. About 30% are spent on air cooling, so that is no longer required. The immersion-based systems, basically with a static tank and a low power pump, are able to bring a data center PoE right down to about 1.1, which is a really good PoE that is traditionally we're not able to achieve that in a data center environment. These liquids have a high dielectric strength, so very much non-conductive, up to 60 kilowatts, volts, higher than traditional mineral oils. I think for those of us who are electrical engineers and used to using mineral oils in transformer cooling and other applications, these special fluids are engineered for server cooling. They have higher dielectric and better dielectric characteristics. Biodegradable is very important, obviously. and they have a long operating life of 10 years in the tank and 25 years shelf life, and they're completely safe for human ingestion, even human touch. They are a little bit more viscous than water, by about 20% more viscosity than water. Yeah, very easy to work with, very, very convenient medium. About 1,600 times the thermal coefficient than traditional air cooling, so that's really where we get the high density of high performance compute cooling that we can achieve through this technology. So in a nutshell, where are we with this technology? It's been around for a few years, it's still relatively niche, but the predictions are that over the next couple of years, from the beginning to by 2030, this technology, in terms of the size of the market, will have grown by about 300%, so significant growth in the technology itself. And also because more and more high-performance workloads are emerging, I think it's definitely what we are seeing in the data center environment over the years. The average power consumption per rack across a data center is only on the increase. So we're seeing it's something that's an inevitable development in the years to come. We have a couple of large brands that have deployed and used this technology. So it's certainly well adopted, well trialed, well working, fully supported. So it's not something that that is new, that is an experiment. We see it in South Africa over the next few years making its entry into the data center industry overseas. All the large data center companies have already started to make provisions in the data center design for it. And certainly data centers in the future will have to respond to customer requirements in a section of a data center where the infrastructure for this type of cooling is required. And that's all for me. Amresh, if there's any questions, happy to field them.
Hi there, Ed from, well, somewhere, I don't know where today. Just to confirm, so with these, the fluid cooling solutions, you would still have some condenser or something outside, or probably like a traditional almost cooling tower that you would have in the water cooling outside the DC, I assume? Or does it use I assume that the two-stage cooling uses a gas to do that?
No, it's, we have a very basic heat exchanger, which is an array of coils and from forced air circulation through it. So the fluid is essentially pumped through the coils on an external device, and only in very extreme cases do they actually require forced air circulation through it as well. The liquid has a very high, very efficient temperature coefficient, so it reduces, it cools down very quickly, but if air circulation is needed, it's applied just through a normal fan application. Thank you.
Hi, this is Nishal, community hat, I guess. Thank you, this is really interesting. This is completely outside my area of expertise, so I'm sorry if I ask a stupid question. But I'm a visual person, so I like to know what this means for me if I go to the data center in the future. Do I need a swimming costume? I apologize if that sounds dumb. I mean, am I expecting to see tanks in data centers? Or what changes? I mean, you're a data center operator. Can you tell us in maybe 3 minutes, I guess, what changes you think you're going to need to do to your data center to be prepared for this sort of stuff? I did listen to your slides. I heard you say that South Africa is coming down the line, but how many years do you think we are away? And what would a data center take? How would they going to the data center to do something actually change? Can you walk us through that process quickly?
Yeah, maybe we'll give them a degree in plumbing first.
Okay.
Or we try and excite them in maintaining their own fish tanks. But essentially, no, you will see a separate section of the data center specifically designed for this type of cooling. So one of the new data center technologies that lends itself, for instance, very well for this are modular data centers. Because you can take a section of the data center and change the infrastructure, the way the infrastructure looks and feels inside that section. So essentially you'll have a part of the data center, could be a separate room, a separate section that doesn't have any raised flooring, that has a number of these horizontal tanks, and you'll have workstations next to those tanks. It's quite safe to put your hands in that fluid, but it leaves a little bit of a soapy residue if you do. So typically what the guys would do, they would be given a pair of silicone gloves, and if they have to take the server out for any work on the server themselves, they would use those gloves, they would work on the server, and they would put it back into the tank. But similar to the vertical rack, the horizontal deployment is essentially just a set of slides facing downwards as opposed to facing horizontally as you would work in that environment.
And then, if you could allow me to sneak one more in, obviously cost is a factor for everybody wanting to deploy in a data center, right? And you already said that the equipment is quite expensive, the fluid and I guess the supporting infrastructure for that. But at the same time, we're looking at not having to deal with the building raised floors, you're looking at lower cooling costs because, well, you know, the atmospheric cooling, I guess, is lower. How do you think that will balance out? Are we looking at a net increase in what it's going to cost to be in a data center, or are we looking at a net decrease?
I think we'll be looking at a decrease.
Okay.
Net decrease, yeah. So,
Hi.
hi.
Evold from Link Solutions. Follow-up question that I was wanting to ask is, what effect does it have on the floor space, since it's now laid out horizontally instead of fitting a bunch of racks in vertically?
Yeah, it certainly has an impact on the floor space because you're not going as high as you used to go with a 47U rack. But at the same time, you're also able to put a multiple amount of workload into a single 47U rack. So a couple of the early stage high performance immersion cooled data centers that we see in the States, they put a whole 1 megawatt data center, which is a significant size data center already in our terms, in a room with 10 racks or even less, you know. So I think you lose on the swings and gain on the roundabouts, essentially. That's my answer.
Okay, and as a follow-up question, will that affect the pricing on each rack since you can fit less?
It'll be, I think, different pricing models, and that'll be more geared around the type of power consumption, the type of cooling that is required. Different liquids also are made for different cooling ranges that you have. So I think the pricing models will slightly change, but we do expect a net small reduction effect, essentially.
Thank you.
Sure.
This is Thomas from Flex Optics. Thank you for the presentation, very nice. I got a question about connectivity. How do you connect the gear when it's submerged? Is it all copper-based, or can you also do this with fiber optic?
Yeah. The connectors themselves don't change. The connectivity itself doesn't change. I think there are quite a few tests still ongoing, but remember, this liquid has got a higher viscosity than water, so it's not as prone in terms of getting in between connections, especially if we're talking about optical connections and things like that. But a huge amount of tests has already been successfully conducted. And if you look at the data sheets of these they're specially engineered fluids. There's a whole range of tests that these liquids have to undergo in terms of being conformed to their non-aggressiveness to the different connector materials that are being utilized. But the connectivity essentially, which is a optical or copper-to-copper or metal-to-metal connection, is not changed.
Okay, thank you very much.
Pleasure.
Thank you, Eckart.
Any more questions?
Any more questions? No. Thank you very much.
Thank you.